Hey, Physics 11 kids, I'm going to do number 4 and 5 from the 2D projectile sheet because somebody asked me nicely to do it. I don't usually do this on a Sunday, but I guess I love you guys or whatever. Okay, so this plane is flying and it's at 81 meters per second, going straight horizontally. And this is a rescue plane and they're dropping supplies. And they're 125 meters up in the air. And when you drop it, it's going to go in a parabolic motion down to your target. And we're looking for what is the horizontal distance that we need to drop it from, I believe is the question. And so there's a couple things you have to realize right off the bat here, that the initial velocity vertically is 0. Okay, that thing is moving, and you might think, well, how can it be 0? It's moving. And it is moving, but it's moving horizontally, perfectly flat. And so vertically, the velocity is 0. Okay, so how are we going to find this dx? Let's do a little bit of physics. Let's look at these steps. Okay, so you want to find dx. Okay, how do you get there? Well, the x velocity is constant. So you could just say d equals vt, and these would both be in the x direction. But we don't know the time, so we're going to have to find that. Okay, so what do we have to do to find the time? There's a couple of different ways. You can use d equals vit plus half at squared. This works, and this is all now, you might be saying, well, how come you all of a sudden went to acceleration? Well, that's because this is now vertically, because gravity is what is determining how long that thing is in the air. And if I dropped something straight down from the plane and it just fell, well, that's kind of what we're doing. If you were sitting in a helicopter, not moving at all, and you dropped it, it would take the same amount of time to fall straight down as if you drop it from a moving plane and it falls down with that horizontal velocity. It's the same amount of time. Okay, and so these are all in the y direction. So it's no longer dx, this is dy. And because the vertical velocity is 0, this would be 0. And so we actually can solve for the time here. And then once we get the time, we can get the dx. Okay, if that is playing with your mind, there is another way you can do it. You can say, well, vf equals vi plus at. That would allow me to solve for the time. But we don't know the vertical velocity at the end. And these would all be in the y direction as well. So you might say, okay, well, first I have to go like that. And so to get this VF, you could use this formula. You could use this with your y displacement because we know that the height of the plane is flying at, and we know a is going to be 9.8, negative 9.8. VIY is 0, so that's gone. And we can solve for the final velocity, plug it in here, use this, rearrange this to find the time, and then we can put the time in here. Or we can come at it from this way and just do it in 2 steps. Just use our d equals half at squared here to find the time, and then plug that in. Let's do it that way. So let's say if dy equals, and this is, now we're going to do the calculation part here, half ayt squared. And this is, I can only do this because the vi is 0, so this is gone, right? So I would rearrange that and I would say 2d over a is would be equal to t squared, right? So the 2, I'm getting rid of the half by putting it over here. I'm getting rid of the a by putting it downstairs here. And I'm going to solve for that t, but I don't want to have t squared, so I'm going to square root it. And if you need to write this out in more steps, of course, that's okay. So the plane was flying at 125 meters high. So you're going to do 2 times 125 over, and the displacement of the package is actually going to be negative, and this is going to be negative 9.8. It's negative because it ends up lower than where it started. So you don't have any weird imaginary numbers as much as Soren wants them. And so that's going to be 250 over about 10 would be 25. So the square root of that would be about 5 seconds, okay? That may be, if you use 9.8, that's going to be 5.1 maybe or something like that. And that's your time in the air. And then, of course, that becomes pretty simple to solve. We just plug that into our next step. And we say our Vx, which is our horizontal velocity, we said was 81. Plane's flying at 81. And that 81 is not going to change the whole way down. When it gets to here, it's going to be going still at 81, but it's going to have some final velocity, and it's going to hit the ground in that actual direction. We don't really need to know this, but if you solved for this, that's great. You might have done that and used it to get the time, and then you're going to do the same step that we're about to do. So our Vxt is 81 times 5, and that's 5 times 8 is 40, and so it's 400, and 1 times 5 is 5, so that's about 405 meters. Now, if you use 9.8, this is going to be 5.1, so I don't know, maybe 410 meters or something like that. If it's anywhere close to that, you're good. The physics is more the important part. Okay, so this is going to end up somewhere 405 to 410 meters. Okay, that's number 4. Number 5 is a little different. It's kind of a weird question. It's a guy driving in a truck, and he's got a bow and arrow. I thought he was shooting it at the duck, but he just shoots it straight up. Why? We don't know. Strange person. And here's this duck up in the air quacking, and he misses the duck, I assume because we don't want to have a bloody mess on our physics sheet. He shoots straight up at 49 meters per second. The truck is driving horizontally at 28 meters per second. And so the first question, A, says, well, how long is it going to be in the air? Okay, so first of all, the velocity of the truck makes no difference to how long it's in the air. So we're going to use our VF equals VI plus AT, and these are both vertical velocities, and of course the acceleration is vertical as well. And we're going to solve that for time. So VF minus VI over A should give us our time, and I'm just going to assume you all know this is vertical. And so my final velocity, if I shoot up at 49, it's going to go up and it's going to come down, and it's going to be at negative 49 when it gets back to the bottom. So this is negative 49 minus positive 49 all over negative 9.8. So that's going to be negative 98 divided by negative 9.8. And of course, that's a nice even 10 seconds. So that's how long it's going to be in the air. B says, how far does it travel in that time? Okay, so let's see if we can fit this in here. And of course, that's just dx, and the dx is going to remain constant. The truck doesn't speed up or slow down. So how far does it travel is just the 28 meters per second times our 10 seconds. So that's going to be 280 meters. That's how far this will travel. So if we're standing here watching it, this arrow is going to go up, and it's going to miss the duck, and it's going to come down like this, and the truck will be over here somewhere, right? So how far will it have traveled? Well, it'll travel 280 meters, okay? Now, if you're standing in the truck, it doesn't look like this, right? If you're standing in the truck, you don't really see the truck moving. You're just going to see the arrow go up, and it's going to flip around, and it's going to come straight back down. And so this is what happens. C asks, where does the arrow come back down? The answer is, comes right back down on the archer, and so he better duck. Actually, he better jump out of the way sideways, because I don't think ducking is going to help him at all. Hopefully that's helpful.